this video, we will be discussing about minimize XOR. Given two positive integers num1 and num2, find the positive integer x such that x has the same number of set bits as num2 and the value x XOR num1 is minimal. Return the integer x. The test cases are generated such that x is uniquely determined. So what they are saying is that in the input, we are given two integers num1 and num2. We need to find an integer x such that this x has the number of set bits equal to the number of set bits in num2. Basically, what is set bit? 1, right? So in a binary representation of a number, we have 1 and 0. So this is unset and this is set, right? So whatever are the number of set bits in num2, x should also have the number of set bits equal to num2. Then this x, when we do its XOR with num1, then whatever is the number that we are getting, that should be as minimum as possible, right? So we need to find such x, and this x we need to return as our answer, right? So if we see over here, 5 in binary is written as 101, right? Now how many set bits are there? Total 2. Then that means in x we need to have 2 set bits, right? Now how do we write 3 in binary? So it is 0 1 1, right? So x we can keep as 0 initially, right? Now in this x we need to set 2 bits, right? Now which all 2 bits should we set? We should set such bits such that this XOR answer that we are getting, this is minimum, right? So before finding out x, let's understand few of the properties. So in an XOR, when we do the XOR of 0 with 0, we get a 0. XOR of 1 with 1, we get a 0. 0 XOR 1 or 1 XOR 0, in both the cases, we get a 1. So these are the properties of XOR, right? Now, if let us suppose I have a binary number something like this. Now in this, the contribution of this bit is 2 to the power 0. The contribution of this bit is 2 to the power 1. This is 2 to the power 2. 2 to the power 3, 2 to the power 4, 2 to the power 5, right? When we try to convert this number into a decimal number, what do? We take this 0 into 2 to the power 0 plus 1 into 2 to the power 1 and so on, right? So if you see over here, the contribution of the bit that is towards the right, its contribution is the smallest, which is 2 to the power 0, that is 1. As we move towards the left, this contribution increases because then we have 2 to the power 1, 2 to the power 2, 2 to the power 3 and so on. So towards the left, this bit, this is having the highest contribution, right? So as we move towards the left, the contribution increases, right? So the bits towards the right, they have the least contribution, right? So we can say these are the least significant bits and these are the most significant bits, right? So now in my x, I need to set 2 bits. Now which 2 bits should I set? So see, 0 XOR 0 will give me a 0. So that is okay. But 1 XOR 0, this is going to give me a 1. And this 1 XOR 0 also will give me 1, right? So wherever in my XOR I am getting a 1, I will try to change it to a 0. Why? Because I need to minimize this number, right? So wherever I am getting a 1, I will try to change it to 0, right? So let me take some random binary number. So 0 1 0 0 1 1 1 0 1 0, something like this, right? And then I will take my x as 0 initially. So all the bits will be 0, right? And let us suppose that the number of set bits that x should have is 7, right? So now, which 7 bits should I set in x? So I see that wherever I have 1 and 0 combination, at all those places I will get a 1 in my answer, right? So I will try to change it to 0. And how can I change it to 0? So if at this particular place I change it to 1, then 1 XOR 1 will give me a 0, right? So what I will do is that in nums1, this is nums1, right? So in nums1, wherever there is a set bit, I will set that particular bit in x also. So in the x, I can only set these many number of bits as 1. So we need to check this also, right? So now we are having 5 ones over here. Now from where you will start changing this 0 from 1? Are you going to start from right to left or left to right? We will start from left to right. Why left to right? Because as I said, the contribution on the left is the largest. So if we try to minimize the contribution from the left, then our number will be as minimum as possible, right? So that is why we will start moving from left to right. and then we will check that in the nums1, where do we have a set bit? So here we have a set bit. So we will set it in X also, right? We will set it in X also. Now we have set one bit, so our number of bits have become 6, right? So we will move forward. This is 0, this is 0, this is 1. So we will set this, then we'll set this also, and this also, right? So at all these places, we will be having a 1, right? Now how many bits we have set? 1, 2, 3, 4, 5, right? So the remaining bits that we need to set are 2. We still have 2 bits to set. Now which 2 bits are you going to set? So see, right now 0 XOR 0 is giving me a 0, 1 XOR 1 is giving me a 0. Everything is giving me a 0 right now, right? So then that means at whichever place I am going to set this bit, I will get a 1 after doing the XOR, right? I have to make 2 more bits in X as set, right? So see, the places where we already have a set bit, that we cannot touch, right? Only the places where we have an unset bit, only at those places we can set bit now, right? So now out of these 5 places, at which 2 places are you going to set the bit? So see, as I said, as soon as I will change a 0 to a 1, I will get a 1 in my XOR, right? So what I will do is that I will try to set the bit towards as right as possible, because towards the right I have the least contribution, right? If I will make this as 1, so I will get a 1 here, and then whatever other bits here. So this number will be greater. But if I change here, so I will get a 1 here, which is very small as compared to the previous approach, right? So for these remaining bits, what we will do is we will start moving from right to left, and wherever we have an unset bit in X, we will set it, right? So these 2 bits we will set now. Now if you see their XOR, so it will be 1, 0, 1, and then everything will be 0. So this is the number, right? And this is our X, which is our answer. This is our answer, right? So basically what we are doing is that first of all, we are identifying that how many set bits do we have in the num2, right? Then we are considering our X as 0 initially. Then we are moving from left to right in num1, and wherever the bit is set in num1, we are setting it in X also till our number of set bits in num2 is greater than 0, right? Now if we are still left with some number of bits, we will start moving from right to left, and wherever in X we have a 0, basically an unset bit, we will set it till our number of bits are greater than 0, right? So this is what we are going to do. So let me remove this. Now coming back to our original example. So here nums2 was 5. We had to set 2 bits in X, right? X is 0 initially, and this is nums of 1. So as I said, we will start moving from left to right. Wherever we have a set bit in num1, we will set it in X also, right? So we will set these 2 bits as 1, and our XOR will be 0, right? So 2 bits we have set. This is 3 in decimal, so 3 is our answer, right? Now the second test case was that nums of 1 is 1 and num2 is 12, right? Now in 12, we have again 2 set bits, right? So if I write a 1, so 1 in binary is 0, 1, right? So my X will be 0, 0. Now in my X, I need to set 2 bits, right? So first I will set this particular bit, right? And then I will start moving from right to left, and wherever I have a unset bit in X, I will set it. So this will be my X, right? If I do the XOR, it will be 1, 0, and this in binary is 3. So in this particular case also our answer is 3. So this is how we are going to solve this, right? Now how do we identify whether a particular bit is set or not? So if let us suppose that I have a number 0, 1, 1, right? This is 0th bit, this is first bit, and this is second bit. Now I want to know whether the first bit is set or not. So what I do is, so see, this in decimal is 3, right? So what I do is I do 3 and 1 left shift I, right? So basically this I is the bit that you want to know. So here I want to know the first bit, right? So I will do a 1 over here. So this basically denotes that in 1 we are doing left shift by 1 position. So 1 in binary is 0, 0, 1, right? Now we will shift all the bit towards the left by 1, right? So this 1 will come here, right? And this 0 will come here, 0 will come here, and then here. Now what we will do is, we will do its AND with 3. 3 in binary is 0, 1, 1. 0, 1, 1. Now when you will do its AND, so this 0 and 1 will give you a 0. 1 and 1 will give a 1 and then all 0. So this is a non-zero value. Then that means the first bit is set, right? Now, if let us suppose that we needed to identify this bit 2. So what would you do? In 1, you would do left shift by 2, right? So 1 would come here and all of these will be 0. And then you would do the AND of 3 with this particular number. So 1, 0, 0 and 3 in binary is 0, 1, 1. So when you will do it and you will get 0, 0, 0. So since this is a 0 value, then that means the second bit is unset, right? So this is how we check whether the ith bit is set or not. And then how do we set ith bit? In X, we need to set some bits, right? So how do we set ith bit? So see, simply what do we do is, so in this example itself, if let us suppose that I want to set this particular bit. So what I will do is that if let us suppose 3 is stored in rest, right? So I will do its OR with 1 left shift I. This I will be 2 in our case. So again, 1 in binary will be this. We will do left shift by 2 times. So we will get 1, 0, 0. And then you will do the OR, bitwise OR of this number with 3. So it will be 0, 1, 1. When you will do its OR, you will get 1, 1, 1. Right? So now this was 3, but now 3 is this because we have set the second bit, right? So this is how we set the bit. So now that we know all the things, let's move on to our code. So first of all, let's take our answer, which will be result, and it will be 0 initially. Then we need to find out that how many bits are set in num2. So in C++, we have an inbuilt function which gives us the number of count set bits, right? So that is known as underscore underscore built-in underscore pop count, and in this we pass num2. So we will get the number of set bits in num2, right? Now what we'll do is we will run a for loop of I starting from 31 and going till 0. So see, the maximum number of num1 and num2 is 10 to the power 9, which has 32 bits, right? That is the reason we are going from 0 to 31, right? And in addition to I greater than equals to 0, we will also have a condition that our target bits are greater than 0, right? And then we'll do I minus minus. So basically, we are moving from left to right, right? And while moving from left to right, we will check that if the ith bit is set in num1, right? If the ith bit is set in num1, then we will set it in our result also. So in the result, we will do its OR with 1 left shift I, right? And we will decrement our target bits by 1. As we are done with this, we will run another for loop of I starting from 0 because now we need to move from right to left, right? And we will go till I less than 32, and while our target bits are greater than 0 and then I plus plus. Inside this, we need to check that if the ith bit is not set in result, right? So we'll put a not and then we'll do the same that ith bit is not set. So if it is not set, then we will set it in the result, right? So it will be 1 left shift I. And we will decrement our target bits by 1. And at the end, we can return this result. So let's run this. So now here we have used the built-in pop count function, which will take log n time. And here also we are iterating for 32 bits, right? So we can say that the time complexity will be log n, and we have not taken any extra space. So it will be constant. So let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.